Algebra Half, Lesson 8, page 31. We're talking multiplying, dividing with powers of 10, and we'll finish with ordering decimal numbers on a number line. Let's imagine we have 10 and we want to have 10 times. Then you do 10 times 10, right? And what's that equal? 100. What if I wanted to use 10 as a factor 3 times? Then I'm doing 10 times 10 times 10. Answer, product, 1,000. Comma if you want it. 4 times, do you already see the pattern? It would be 10,000. Okay, so all of these are considered, what we say, powers of 10 because they're all products found by just multiplying 10 by itself. Okay, it's not 10 times 3, that's not a power of 10. 30 is not a power of 10. But 10 times 10 times 10 to get 3 zeros is a power of 10. Powers of 10 are all about zeros. If you have 10 as a factor twice, your product has 2 zeros. 10 as a factor 3 times, 3. And just imagine how many times did I use 10 as a factor for 10,000? 4 times. And it would go the same for if I used 10 as a factor 8 times, it would be, I guess it would be a trillion, right? No, 8 times would be 100 million. And you can find that on the bottom of page 31. When we multiply any number, let's say 4.32, by a power of 10, which could be any really product of tens, let's use 1,000, all it is a matter of moving our decimal point, okay? Because it's just about the zeros. So you count how many zeros and you move the decimal point that many times. But the hardest part with this is knowing whether to go left or right. Well, think about it. Which number is bigger, 4.32 or 0.0432? Well, obviously, it's this one. Well, to get to here, I had to move the decimal point left and make it smaller. To get to here, I moved the decimal point to the right to make it bigger. So right is big, left usually small. Okay? So if I multiply by 1,000, shouldn't it get bigger? Absolutely. So we move it the number of zeros. 1, 2, and our new number would be 4,320. I moved it 3 times. Okay, but if I had this number over here and I multiplied by 1,000, I'd have to move it past this 0, 4, and our new number would be what? 43.2. Get rid of that. Erase it. So move right for big, left for small. Look at this number. I've got 0.031652 or 31,652. I don't even know what place value this is. Tenths, hundredths, thousands, 10,000s, hundred, millionths. 31,652 millionths times 10,000. Should my number get bigger when I multiply by 10,000 or smaller? Bigger or smaller? Bigger, absolutely. If it trips you up to think of this decimal about getting it bigger, then just think, what if I only had 3, not 0.03, but 3 times 10,000 is the number. Bigger or smaller as a product? 30,000, much bigger. Same thing with this, except we're starting with a number that's less than 1. So jump how many zeros? 1, 2, 3, 4, 5, right? 1, 2, 3, 4. 1, 2, 3, 4 zeros. I always want to count this 1 and it doesn't count. So just go 4 humps. 1, 2, 3, 4 and get rid of this hump. Dot goes there. Okay, so final answer 316.52. You can check that answer at top of 32. Example 8.2. They do another one where they already have 47,000 and they multiply by 100. Multiplying by 100 should make the number bigger, right? So at the top of 32, you see it just adds 2 zeros. Actually, no, it moves the decimal point right 2 places so that the decimal is right in front of the 4. It's all about zeros, left or right, and moving your decimal. Now, powers of 10 are always going to be making it bigger if we multiply. These numbers should make it bigger. But what about when we change the operation? Okay, now if I divide by 1,000, shouldn't I get smaller? Absolutely. So when you divide, you get smaller. When you multiply, you get bigger. As long as you're multiplying or dividing by whole numbers, like 1,000. How many places? 1, 2, 3. So 1, 2, 3 places to the left, because we're getting smaller, we're dividing. What do I do with this spot right here? I have an extra empty space. I took this one from example 8.3. I'm going to have to put a 0 there. 0 for 1, 3, 2. So I moved my decimal over 3 spots to here. Okay? Making some sense, I hope. Lastly, we want to be able to order decimal numbers from least to greatest. Least is always on the left of your number line, greatest to the right. Let's just throw a line down. Okay, we got our arrows, of course, always. What color should I use? Can you guess it? Can you guess it? I'm going to use blue. We're going to use warrior colors today, like that. 0, right in the middle, the origin. Now, I need to order these numbers. How am I going to go about it? You probably all have your own strategies, but you notice all of these are less than 1, which means they're all going to be on this side of the decimal point. Now, where do I put them? They're all less than 1, so they're all between 0 and 1. We probably have to zoom this in a little further, but we're going to use this for now. Now, which order do we have? Well, closest to 0 I'm sorry, this is kind of messed up. Let's take this and no, just undo those. Let's put 4 on the end. No, let's put 0 here. Let's put 0.5 here to help us visualize, and let's put 1 here. Okay, so we are to the right of the 0. It's less than 1, but it's positive. That was my mistake there for a second. Positives to the right, negatives are what's down here, and we're not dealing with those right now. So less than 1 is still more than 0. Now we're dealing with decimals. Start with your first digits. Which one has the biggest digit to the right of the decimal? I have a 4, a 0, a 7, and a 0. Okay, 0.732 has the biggest number to the right of the 0, or to the right of the decimal point. So it's the biggest one. It's somewhere over here, 0.732. Okay, next. Which one is the next biggest? 0.426. Is that more than 0.5 or less? Just less. 0.426. Next. 0.0. Okay, now we have to go to the next spot. Which one is the next biggest? 0.0732. Looking at that 7. And finally, 0.0426 would go about here. So our order is 0.0426, 0.0732, 0.426, and 0.732 from least to greatest. You're going to need to do that on practice F, least to greatest, with some decimals. You'll also want to pick one, A through D. So A through D, pick one, and then do F. So 2 total. Okay? Good luck.